Okay, so yesterday we have started with the introduction to electric vehicles, and we have seen what problems arises when we are using the gasoline powered vehicle, right? We have talked about the air pollution, we have talked about the greenhouse effect, and then the depletion of these petroleum resources. Okay, so these three are the main reasons why the public has shifted now again to the electric vehicles. So a lot of research and developments are going on in electric vehicles as well as hybrid electric vehicles, right? So basically these electric vehicles paved their way into public use as early as the middle of the 19th century, right? Even before the introduction of gasoline powered vehicles, right? We have seen in the year 1900 almost 4200 automobiles were sold. If I talk about the year of 1900, then we will see almost 4200 automobile vehicles were sold, right? And if I divide this vehicle into the categories percentage wise, then out of this 4200 automobiles, 40% of the automobiles were steam powered. Right? Then 38% of the automobiles were electric powered. And 22% were gasoline powered. So this was the ratio in 1900, right? After that, what happens? The invention of the starter motor was there, okay, and improvement in mass production technology of gas powered vehicles comes into the picture. And on the other hand, there was inconvenience in battery charging, which led to the disappearance of the electric vehicles in the early 1900s, right? However, the environmental issues and the unpleasant dependence on oil lead to the resurgence of the interest in electric vehicles in 1960s. Okay, so growth in the enabling technologies added to the environmental and economic concerns over the next several decades, increasing the demand for investing in research and development for electric vehicles, right? So interest and research in electric vehicles soared in 1990s, with the major automobile manufacturers embarking on plans for introducing their own electric or hybrid electric vehicles. Okay, and this trend increased today. Okay, with electric vehicles serving as zero emission vehicles and hybrid electric vehicles already filling in for ultra low emission vehicles, right? So this is what we have seen the history of electric vehicles, hybrid electric vehicles, and fuel cell in the last session. Now in today's particular session we are going to see the introduction of electric vehicle system, right? What are the components of an electric vehicle systems? History we already have seen. Then we will be seeing some efficiency matters of electric vehicles, right? What are the advantages of vehicles? We will try to compare the efficiency, we'll try to compare the pollution generated, right, etc, etc. Okay, so let us start with the electric vehicle systems, right? This was the our first step toward studying the electric vehicles. Okay, so we were talking about electric vehicle system, right? So basically if I talk about this electric vehicle, then this electric vehicle has two particular features. If I talk about the features, then this is the energy source which is portable, right? So I am talking about the energy source This is my first feature of electric vehicle. Energy source is portable and chemical or electromechanical in nature. Chemical or electromechanical in nature, right? And second, if we talk about the traction effort, then this traction effort is supplied only by an electric motor. Okay, this is the second feature, that traction effort is supplied only by an electric motor. Okay, so these are the two typical features of electric vehicle system, right? Now if we talk about the perspective of an electric vehicle system, then what will be there, right? So particularly we'll know that this is my typical vehicle. Okay, so we have to run some wheels, right? So we are available with these wheels over here. Okay, these are my wheels, right? And with the help of motors and batteries, we need to run these particular wheels. Okay, so to drive these wheels, now we will require the shaft. Okay, so we will require some transmission. So this will be our transmission, or we can say drive shaft. Transmission and drive shaft, right? And this transmission or shaft which is propelled will be with the help of electric motor. Okay, so here comes the main part of electric vehicle, which is electric vehicle. Okay, whatever traction effort, tractive efforts are required, this electric vehicle will provide that much amount of tractive effort. So this is my electrical motor, right? And to feed this motor, we will be requiring some converter, because this is an moving vehicle. Okay, we are moving the vehicle and we are going to supply this motor with the help of some battery. And if we know the nature of the battery, then battery will have a DC supply, right? So we need to convert this DC supply into AC supply if we are going to use the AC motors. Okay, it will be good if we are going to use the DC motor. Okay, and research says that most of the companies are using AC motors as well as DC motors, depending on their view or their research and their efficiency of the device. So what we require, we will require one converter, which is a power converter, because ultimately we will have to provide the variable voltage to this electrical motor, or we need to change the frequency of this electrical motor. Okay, so to get the speed control and overall control of electrical motor, we will require one power converter. Okay, so before electrical motor, we will be having one power converter. Okay, now this is my power converter or power circuit, right? So we will give command to this power converter. Okay, suppose I want to increase the speed, then I will give command accordingly. So this power converter will be fed by some signals. Okay, some controlling signals, right? So here we will provide some drive control signals. drive control signals, right? And this converter needs to be fed with the supply voltage, right? So here we will use our source of energy, which is nothing but the battery in our particular case, right? So this is my energy source. Okay, this is battery, nothing else, right? And we will require to charge this battery, and that is why there is one more component we need to add is the charger over here, right? So this is the top level perspective of an electric vehicle system. Okay, you can say the generalized block diagram of EV system. We'll call it top level perspective of an EV system. Okay, so you can see this particular system driven by a portable energy source, right? And the electromechanical energy conversion linkage system between the vehicle energy source and the wheels is the drivetrain of the vehicle, right? And this drivetrain has electrical as well as mechanical components, right? So now what are the components are there? If I talk about the transmission or drive shaft, then what components are available? If we talk about the motors, what are the types of motor? What will be the design of the motor, right? If I talk about the power electronic converter, then what are the topology of these converters and what devices are going to use in this particular case, right? So we will talk about each and every case, right? And hence we need to talk about the components of an electric vehicle, right? So the primary component of an electric vehicle systems are the motor, controller, power source and transmission, right? That is what we have seen, right? Now let us go into the detail. Okay, let us try to elaborate the detailed structure of an electric vehicle system and the interaction among its various components. Okay? So let us now see the components of an electric vehicle, right? This was the generalized overall block diagram, overall system, where we have one converter, we have one motor, we have one transmission system, and then there is an wheels, right? So our second topic will be components of electric vehicles, right? So we will start with the first of our electronic controller now, right? So we do have our electronic controller over here, right over there. Okay, this is my electronic controller, right? Okay, so to this electrical controller, what we will be doing, we are providing the signal, the drive signals. Okay, whether I want to accelerate my car or if I want to apply the brake to my car. Okay, so we will have one pedal. You know, there is available with one pedal in the car with which you can accelerate or apply brakes, right? So one of the input to this particular electronic controller now will be the pedals, right? So we will call this as user inputs. Okay, it may be acceleration or it may be a brake. right? And this particular electronic controller, now if I talk about the electronic controller, then this electronic controller will have one hardware and one software, right? So if I talk about the software of the controller, suppose we talk about the software of the controller as well as hardware of the controller, right? So in case of software, what we will have, we will get the different kind of controls. Okay, some classic controls will already be there and some modern controls will always be there, right? So let us say this software will have some classic control and some modern controls, right? And if I talk about the hardware, now control means we should have the controller, right? So number of controllers available into the market and most widely used controllers are microprocessors or even digital signal processors called as DSPs. Okay, so we may select a microprocessor or a microcontroller and digital signal processors which are famously known as DSPs. Okay, so in electronic controller we may have these particular things. We may available with microcontroller, microprocessor or DSPs, and software may have the classic controls as well as modern controls, right? Now this signal needs to be provided to power electronic converter, right? So we will be having next our power electronic converter. Right, and these two blocks, electronic controller and power electronic converters, are two-way blocks. Okay, because we will be taking some feedback and that feedback again will be given to the electronic controllers, right? Now talking about this power electronic converter, you already have gone through the power electronic subjects also, right? So we know each and every topology we can use in this power electronic converter, right? And what are the devices that you may find in this power electronic converters? Okay, so the first thing we need is the different devices that are used and what topology we will be using in this particular converters, right? So in this particular case now, devices may be silicon controlled rectifier, bipolar junction transistors, MOSFET, IGBTs, gate turn off thyristor. Okay, so lots of devices are available. Okay, so these are some of the famous devices which you will find frequently in power electronic converters. And if I talk about the topology, then mostly see we are available with some motor, right? And that motor may be an AC motor or maybe an DC motor, and we are taking supply from the battery which is DC. Okay, so if it is a DC motor, then we will be requiring DC to DC converter. Okay, this was our first topology, that we will be requiring DC to DC converter, or if motor is AC, then we will be requiring DC to AC converter, right? So we are talking about the choppers as well as inverters. Okay, apart from this we have lots of converter, right? Say like pulse width modulated inverter, resonant converters, say PWM, resonant converter, and short switching converters also, right? So these are the different converters which we have seen, right? Now this we were talking about the power electronic converter. Okay, and this power electronic converter, as we have seen earlier, it is connected to this electric motor. Okay, so my next block will be a motor. Okay. So this power electronic converter is connected in two ways. Okay. Whenever we are going to accelerate, then flow of power will be from converter to motor, right? This is my motor. And whenever we do apply braking, at that time power flow will be from motor to the source, that is converter, which we call a regenerative braking. Okay, as we have discussed in last session that we do not apply dynamic braking, but instead we will be using this regenerative braking. What does it mean? We will try to utilize the kinetic energy while braking, right? Okay, now coming back to the motor. So we are available with the different types of motor, right? If I talk about the types of motor, then we are available with some direct current motor, DC motors. Then we are also available with AC motors, which are known as induction motor, right? And apart from these conventional AC and DC motors, lots of other motors are available into the market, and lot of research is going on with that particular kind of motors. Okay, so the most famous motor is permanent magnet synchronous motor. Okay, we are going to see each and every motor in coming lectures, right? Then there is one brushless DC motor. Okay, then switch reluctance motor known as SRM, and there is one more motor which is synchronous reluctance motor. Okay, so these are the different kinds of motor which we will be able to use in this electrical machine. Okay, and again this motor should also have some design. Okay, so design using some finite element or using CAD or materials or packaging, some mechanical parameter, some thermal parameter. Okay, so each and every parameter we need to count while designing the particular motor. Okay, so design is one more aspect in case of motors. Okay, so this belongs to motor, this also belongs to motor. Okay. So if I talk about design, then we must have some finite element design, finite elements, then computer aided drafting known as CAD. Then you must know about the materials. We must know about the packaging. You must know about the mechanical property of the machine as well as thermal properties of the machine. Okay, so this design belongs to an electrical motor, and there comes the transmission. Okay, so here we will have some drive shaft, or you can say transmission, right? And then there comes our wheel, right? So we'll be having some wheels that are connected to this differential. This will be my wheel. And this is my differential. Okay. So this is our block diagram with the components we are going to use in it, right? Now this electronic controller, or if I talk about the power electronic converter, then these two converters are fed with the battery, right? So here we will be having some battery. Okay. Now there is also two-way communication, because whenever we are accelerating, at that time this converter will draw the power from the battery itself. Okay. So this is my batteries, or we can say source. Okay, and whenever we apply regenerative braking, at that time whatever kinetic energy is there, this kinetic energy is being converted into electrical energy, and it will help to charge these batteries. Okay, so there is always a two-way communication in this particular case, right? And then we are available with the charging circuit. Okay, so there will be a battery charger over here. Right, and this motor, now this motor will give feedback to the controller, to the control system. Okay, and then we have our control system over here. Okay, so we will be taking some feedback from the motor, and that feedback will be fed back to the controller or a control system. Okay, and this electronic controller also require the power, so that power will be delivered by this source, or you can say battery. Okay, so these are the major electrical components as well as the choice which we are available with for an EV system. Okay, so these are major electrical components and choices for an electric vehicle system, right? Okay, so what this particular figure shows, it shows the choices available for each of the subsystem level components. Okay, electrochemical batteries have been the traditional source of energy in electric vehicles. Okay, for example, lead acid batteries have been the primary choice because of their well developed technology as well as lower cost, right? Now, but nowadays what will happen, the promising new battery technologies are being tested in many prototype vehicles. Okay, these batteries need a charger to restore the energy level once its available energy is near depletion due to usage, right? The alternative energy sources are also being developed for zero emission vehicles. The limited range problem of battery driven electric vehicles prompted the search for alternative energy sources such as fuel cells and flywheels, right? So the prototypes have been developed with fuel cells while production vehicles will emerge in the near future. Okay, so talking about the majority of electric vehicles which are developed so far are based on DC machines, induction machines, or permanent magnet machines. Okay, so the disadvantage of these DC machines push the electric vehicle developers to look into the various types of machine, right? So we know what are the advantages of AC machines by now, right? It is maintenance free, low cost, right? These are the advantage of induction machines, and this became an attractive alternative to many developers, right? But however, high-speed operation of induction machine is only possible with a penalty in size and weight. That also we know, right? The excellent performance together with the high power density features of permanent magnet machines make them an attractive solution for electric vehicle applications. But the cost of these permanent magnets can become prohibitive, right? So high power density and potentially low production cost of switch reluctance machines make them ideally suited for electric vehicle applications. But the acoustic noise problem has so far been a deterrent for the use of these switch reluctance machines in electric vehicles. Okay. So the electric motor design includes not only electromagnetic aspect of the machine, but also thermal and mechanical considerations. Okay. The motor design tasks of today are supported by finite element studies and various computer aided designing tools, making the design process highly efficient, right? So the electric motor is driven by a power electronic based power processing unit that will convert the fixed DC voltage available from the battery into a variable voltage variable frequency source control to maintain the desired operating point of the vehicle. Okay, so this power electronic circuit comprised of power semiconductor devices saw some tremendous development over the past 3 decades. Okay, the enabling technology of this power electronic is a key driving force in developing efficient and high performance powertrain units of electric vehicles. Okay, these high power devices in compact packaging are available today, enabling the development of lightweight and efficient power processing units known as power electronic motor drives. Right? So advances in this power solid state device and very large scale integrations, which is known as VLSI technology, they are responsible for the development of efficient and compact power electronic circuits. Okay? So the development in high-speed digital signal processors or microprocessors enable this complex control algorithm implementation with a high degree of accuracy. The controller includes algorithm for the motor drive in the inner loop as well as system level control in the outer loop. Okay, so this is a small introduction of these major components and their choices for an electric vehicle. Although we will go through each and every component as well as each and every topology or even each and every motor which we have seen. We will see some induction motor drives, we will going to see some DC motor drives as well as other special purpose machines also. Right? And talking about the electric vehicle history, we already have gone through it, right? So we have seen what happens in 1950s, 1960s, 1990s, etc. etc. Right? Now, whenever we are looking for one particular machine, one particular vehicle, whether it is an electric vehicle or other vehicle, right? He must have some performance standardization, right? If I am making one electrical machine, then what are the performing parameters of that electric machine? That is also a necessary thing, right? So we have some standardization of the performance for electric vehicle system, okay, for personal use as well as for commercial use, right? What should be the range for electric vehicle, what should be the range for hybrid vehicles, right? What should be the time for acceleration from 0 to certain kilometers, say 0 to 50 kilometer per hour, right? What will be the gradability at different speeds, right? So we have some standardization which is called as EV performance standardization, and it was established in 1976. Okay, so let us go through this standardization and then we'll move on to the case study of two vehicles, right? So let us say we are talking about electric vehicle performance standardization, which was in 1976, right? So there are different categories of this standardization. We will see this category one by one, and they were used for personal use as well as commercial use. Okay, so let us start with the first category. The first category we are going to consider is the acceleration of the electric vehicle from 0 to 50 kilometer per hour, right? So the acceleration from 0 to 50 kilometer hour, if I use for personal use, then it should be less than 15 seconds. Okay, and for commercial use also it should be less than 15 seconds. If I talk about the gradability, at 25 km per hour, then for personal use it should be 10%, and for commercial use also it should be 10%. Let us now consider the gradability at 20 km per hour. Okay, we'll go by this term gradability also in the coming lectures. Okay, so gradability at 20 km per hour should be 20% for personal as well as commercial use, right? Then we should look about the speed, forward speed. Okay. Say if I run my electric vehicle for say 5 minutes in forward direction, then it should achieve the speed of 80 kilometers per hour. And for commercial vehicle, it should be 70 kilometer per hour. Okay, now this range is extended in the new standards. Okay, but we are talking about the standards which was established in 1976. Okay, then let us talk about the range of electric vehicle. Okay, so as we know, we are available with two kind of electric vehicle. One is the complete EV, that is electric vehicle, and another one is hybrid electric vehicle. Right, so talking about the electric vehicle, the range for personal use should be 50 km per charge cycle. And for commercial use also it should be 50 km per charge cycle. Okay. And for hybrid it should be 200 km in both the cases. Okay, 200 km. Right. Now the most important thing, that is the charging time, right? When I lost my energy from the battery, I need to recharge, right? So what should be the charging time? Nowadays, lots of fast chargers are also available into the market. But what will happen when we use the fast charger? Then charging time will definitely get reduced, but it will affect the age of the battery. Okay, say for normal charging, if my battery runs for 3 to 5 years, right, and using the same fast charging, my battery may die in 1 or 2 years also, right? So depending on our requirement, we should use this fast or low charge. Okay, so one of the most important parameter or category was recharge time. Recharge time from 80% of discharge. Right. So as per the standards defined in 1976, this discharge time must be less than 10 hours for personal vehicles as well as commercial vehicles. Okay, so this was the performance standardization of 1976. Right. Now, the General Motors we have discussed yesterday. The General Motors has introduced their electric vehicles in 1970. Right. So what was there? And let us try to see the case study of two particular vehicles which were there in 1970s, right? So let us have a case study of General Motors electric vehicle. Okay, so if I talk about the motor, then they have used separately excited DC motor. Separately excited DC motor of 34 horsepower and 2400 revolutions per minute. Okay, if we talk about the battery, Then they have used nickel zinc battery of 120 volt, right? And they have also used one auxiliary battery of 14 volts, same made nickel zinc, right? And then to drive the motor, they were using the DC chopper. Okay, so let us talk about the motor drive. Okay, they were using DC chopper using SCRs. Okay, and this one was for armature. If I talk about the field, then in that case there was a DC chopper using BJTs. Okay, this was for field, right? And if I talk about the top speed achieved by this, then it was 60 miles per hour. Okay, and range for a single charge was 60 to 80 miles, of course depending upon the condition of the road, right? And if I talk about the acceleration, then acceleration was 0 to 55 mile per hour in 27 seconds. Okay, and this particular vehicle utilized the modified Chevy chassis and the body. Okay, so this electric vehicle was used mainly as a test bed for these nickel zinc batteries. Okay, over 35,500 miles of on-road testing proved that this electric vehicle was sufficiently roadworthy. Okay, it was ran for 3,500 and 5,000 miles. Okay, it was developed by General Motors in 1970s, right? Then in 1980s and 1990s, there were tremendous developments of high power, high frequency semiconductor switches along with the microprocessor revolution, which led to improved power converter design to drive these electric motors very efficiently, right? Also in this period, factors contributed to the development of magnetic bearings which are used in flywheels energy storage systems. Okay, although these are not utilized in mainstream electric vehicle development project. Okay, so you're talking about the last 2 decades. In last 2 decades, the legislative mandates pushed the cause for zero emission vehicles. Okay, if I talk about the legislation passed by the California Air Resources Board, which was passed in 1990, it stated that by 1998, 2% of vehicles should be zero emission vehicles for each automotive company selling more than 35,000 vehicles. Okay, so the percentage were to increase to 5% by 2001 and 10% by 2003. Okay, and this legislation provided a tremendous impetus to develop electric vehicles by the major automotive manufacturers, right? This legislation was relaxed somewhat later due to the practical limitations and the inability of the manufacturers to meet the 1998 and 2001 requirements. Okay, and this mandate now stands that 4% of all vehicles should be zero emission vehicles by 2003, and an additional 6% of the sales must be made up of zero emission vehicles and partial zero emission vehicles, which would require the General Motor to sell about 14,000 electric vehicles in California, right? So this was the legislative passed in California by their air pollution board, right? So the trends in electric vehicle development in recent years can be attributed to some factors, and this factor is the high level activity exists at the major automotive manufacturer. Then new independent manufacturers bring vigor. Right? New prototypes are even better. High level of activity overseas exist. Okay, and there are high level of hybrid vehicle activity. Okay, there is a boom in individual internal combustion engine vehicle to electric vehicle conversion is ongoing. And also we talk about the fuel cell. The fuel cell shows great promise in solving the battery range problem. Okay, so these were the things, and it increases day by day. Now suppose I talk about the two vehicles which was made by the General Motors in 1990. Okay, now we are talking about 1990s. In that, General Motors have launched their electric vehicles Impact 3. Okay, it was completed in 1993. Right. So it was a two-passenger, two-door coupe and street legal and safe. Okay, and they were 12 in number. Okay, initially they have built 12 for testing, and then they have built 50 by 1995, and that is to be evaluated by 1000 potential customers. And if I talk about the motor, then now they have used three-phase induction motor worth 137 HP. Okay, and the speed was 12,000 RPM. Now compare with the machine which was developed in 1970. The motor was 34 HP and 2400 RPM. Now it is 137 HP and 12,000 RPM. Also motor is replaced by induction motor now. Okay, and they have used the lead acid battery now. Okay, they have connected 10-volt batteries in series, right? And then if I talk about the converter, definitely AC motor is there, so DC to AC inverter was used. Okay, having IGBTs as power switching devices. Okay, the top speed achieved by this machine was 75 miles per hour, and its range was 90 miles. Of course, on highway, it was tested on highway only, right? And acceleration will be 0 to 60 miles in just 8.5 seconds. Okay, so this was the case, right? And this vehicle was used as a test bed for mass production of electric vehicle systems. So this is our first particular case, right? Now if I talk about the second machine, okay, the second machine was the Saturn electric vehicle 1. Okay, it was Saturn EV1, right? And it is commercially available electric vehicle which was made by General Motors in 1995. Okay, and the cost of this motor was 30,000 US dollar. Okay, this was the cost of the motor, 30,000 US dollar. And if we talk about the characteristic of this particular motor, then again they have used three-phase induction motor. Battery was lead acid battery again. Okay, and same converter, DC to AC converter using IGBTs were there. Okay, top speed was 75 miles per hour, and range, if I talk about the range, it was 90 miles on a highway and 70 miles in the city. Okay, and the acceleration was 0 to 60 in just 8.5 seconds. Okay, so this was the case. Now, if I compare this particular vehicle with the previous one, that is impact 3, then almost all the specifications are same, right? Range is also same, the acceleration time is also same, etc., etc. And now if I talk about the power consumption, which is our interest, right? So power consumption for this vehicle was 30 kilowatt per hour per 100 miles in city and 20 kilowatt per hour per 100 mile on highway. Okay, and this vehicle also used as a test bed for mass productions of electric vehicles, right? So this was the two typical case studies, two typical motor, or we have seen some advancement in the manufacturing of electric vehicles. Earlier we have seen that they were using DC motors. Now this DC motors has been replaced by the induction motor. Even these induction motors have been replaced by some switch reluctance motors or synchronous reluctance motor. Okay, so we need to study each and every motor drive. Okay, we already have gone through different drives in your electric drives subject, right? So all of the major automotive manufacturers have production electric vehicles, many of which are available for sale or lease to the general public, right? The status of these vehicle programs changes rapidly, with manufacturers suspending production frequently due to small existing market demand of such vehicles. Okay, so example of production EVs which are or until recently have been available are General Motors EV1, Ford Think City, Toyota RAV4, Nissan Hypermini, and Piguet 106 electric. Okay, there are also many prototype and experimental electric vehicles being developed by major automotive manufacturers, and most of these vehicles use AC induction motors or permanent magnet synchronous motors. Also, interestingly, almost all of these vehicles use battery technology other than lead acid battery pack. Okay, the list of electric vehicles in production and under development is extensive, and you are referred to some literature will provide you later on for details of these many vehicles. Okay, so the manufacturers of electric vehicles in 1990s realized that their significant research and development efforts on zero emission vehicle technologies were hindered by unsuitable battery technologies. Okay, so a number of auto industries started developing hybrid electric vehicles to overcome the battery and range problems of pure electric vehicles, right? The Japanese auto industries lead to this trend with Toyota, Honda, and Nissan already marketing their Prius Inside and Tino model hybrids. Okay, the hybrid vehicles use an electric motor and an internal combustion engine, and thus do not solve the pollution problem, although it does mitigate it. Okay, it is perceived by many that the hybrids with their multiple propulsion units and control complexities are not economically viable in the long run, although currently a number of commercial prototype and experimental hybrid vehicle models are available from almost all of the major automotive industries around the world, right? So these are some recent trends in electric vehicles as well as in hybrid electric vehicles, right? So we have seen today the typical block diagram of electric vehicle systems and the components used in electric vehicle systems. Okay, so what we are going to do in further lectures is nothing but we are going to study all these choices. Okay, what should be the induction motor drive, what is PM synchronous motor drive, brushless SRM, brushless motor drives, SRM motor drives, synchronous reluctance motoring, then also energy management strategies. What should be the battery how we are going to charge this battery, what are the different charging methods available to us, etc., etc. Okay. So in coming lectures, we will start modeling a particular vehicle. We'll try to understand the general description of the vehicle movement, like its resistance, its dynamic equations, and other tractive effort required, maximum and minimum tractive effort requires, right? Okay, so we will stop here for today. In the next lecture, we'll continue with the basics of these electric vehicles, or you can say vehicle fundamentals, right? If you have any questions, then you're free to ask, or else we'll stop.